IE10. This is our final lesson for the topic of equations, and this topic is part of the advanced pathway for the new New South Wales curriculum. In this lesson, we're going to look at simultaneous equations. So this is what we've covered so far in the topic: linear equations, literal equations, quadratic equations, and last lesson we looked at the discriminant. Recall that there are three methods for solving simultaneous equations. There's the elimination method, the substitution method, and the graphical method. Now, when one of the equations is nonlinear, it's not practical to use the elimination method, but we'll get to that in a little bit. So I'll quickly revise the graphical method. Solve the simultaneous equations by finding the point or points of intersection. So y equals 2 on x and y equals x plus 1. Now I'm not going to go through how to graph these two functions because we will do that in a different topic. But suppose we were given the graphs. If we want to find the solution to the simultaneous equations, then that's the point or points of intersection. So the solutions are x is equal to -2, y is equal to -1, and x is equal to 1, y is equal to 2. And you can write those as points if you want to. Okay, so let's revise the elimination method. Now, as I said, this is perfect for linear relationships, but no good at all for non-linear relationships. The elimination method involves eliminating one of the variables, and it doesn't matter which one. So let's have a go at solving 2x plus y is equal to 4, 2x minus y equals 8. Now, because these coefficients match, we could subtract this equation from this one, and that would eliminate the x's. But the size of the coefficient for y also matches, and we have different signs, so we could add these two equations together and eliminate the y. Now, because adding is always easier than subtracting, let's add them together. So 2x plus 2x is 4x, y plus -y is 0, 4 plus 8 is 12. And solving x must be equal to 3. Now we're not finished, we need to also find out what the y value is, so we need to substitute back into one of the original equations, and it doesn't matter which one. So we'll just choose the first one, 2x plus y is equal to 4. Substituting in, we get 2 times 3 plus y is equal to 4. Y must be equal to 4, take away 6, which is -2. And so the solution is x equals 3, y equals -2. Now sometimes we have to multiply one or both equations by a number so that a variable can be eliminated. If you have a look here, neither the x coefficients nor the y coefficients match. So adding or subtracting is not going to eliminate a variable. But if I multiply this one by 2, I will end up with 2y here. I'm going to start by saying let this be equation 1 and this one be equation 2, and I'm going to multiply equation 1 by 2. And that will give me 4x plus 2y is equal to 6, and equation 2 stays the same. Now, are we going to add these together or subtract them? Because the signs are the same, if I add them, I'm going to end up with 4y here. It won't eliminate, so I need to subtract. 4x take away 3x is x, 2y take away 2y is 0, 6 take away -1, be careful here. 6 take away -1 is the same as 6 plus 1. So x is equal to 7. Now let's substitute back into 1. And that's going to give us 2 lots of 7 plus y is equal to 3. Y is equal to 3 take away 14, which is -11. Now we use the substitution method when the two equations aren't in the right form for elimination. And we can use this with nonlinear or linear equations. So you can see here, we don't have the right setup for elimination. So we've got y is equal to this, and then we've got general form here. Now what we do is substitute in for y. Be very careful with negatives with this method. So 2x plus 1 is going to go in there. It needs to go in brackets. Tidying this up, we get x take away 2x, take away 1, take away 3 equals 0. So x take 2x is -x, and this is -4. And I'm just going to take this x over the other side. That will make it positive. So x is equal to -4. Substitute back into this equation. Y is equal to 2 lots of -4 plus 1, which is -7. So our solution is x is equal to -4, y is equal to -7. So let's do one more pair of linear equations before we move on to nonlinear. 3x equals 2y plus 1, y is equal to 3x, take away 5. All right, we're going to substitute for y, 3x take away 5, and we're going to put it in brackets. Expanding through, we're going to get 6x take away 10. Tidying this up, that's negative 9. Now this, I'm going to take this 3x over here. That's going to give me 3x here, and I'm going to take the negative 9 over that side. So 9 is equal to 3x, divide by 3, x is equal to 3. Substitute back into here, because we've got y as the subject, so y is going to be equal to 3 times 3, take away 5, which is 4. Our solution is x equals 3, y is equal to 4. Now let's look at some nonlinear simultaneous equations, and I'm going to use the substitution method. So in this case, I'm going to substitute 2x minus 5 for y. Now we can see that we're going to get a quadratic here, and we're probably going to get two solutions. So tidying this up by taking these two over the other side, I end up with x squared minus 5x plus 6 is equal to 0. Now assume that you're going to be able to factorize this. And we can, can't we? It's x minus 2 multiplied by x minus 3. So x is either equal to 2 or 3. Now we're not finished because we haven't got any y coordinates. We need to substitute x back into here to get the y coordinate, and then substitute 3 back into here to get the y coordinate. So when x is equal to 2, y is equal to 2 times 2 take away 5, which is negative 1. And when x is equal to 3, y is equal to 2 times 3 take away 5 equals 1. So our solutions are x is equal to 2, y is equal to negative 1, x is equal to 3, y is equal to 1. Let's try another one. Solve the following simultaneous equations. Y equals 2 over x, y equals x plus 1. So I'm going to substitute x plus 1 for y. X plus 1 is equal to 2 over x. Now do you remember how to solve an equation like that? I need to get that x off the denominator, and the way to do it is to multiply every term by x. Like this. And these cancel. So tidying up, we get x squared plus x is equal to 2. Taking our 2 over, x squared plus x minus 2 is equal to 0. Assume that you can factorize. And we can, can't we? It is x plus 2 in brackets multiplied by x minus 1 in brackets is equal to 0. So x is equal to negative 2 or 1. Now we need to substitute both of those back into one of the equations to find the corresponding y coordinates. So we'll start by substituting negative 2 back into here. When x is equal to negative 2, y is equal to negative 2 plus 1, which is negative 1. When x is equal to 1, y is equal to 1 plus 1, which is 2. So our solutions are x equals negative 2, y is equal to negative 1, and x equals 1, y is equal to 2. Okay, let's finish off with a word problem, because we can get word problems with nonlinear simultaneous equations as well. Two numbers multiply to give 1 and add to give 61 on 30. What are the numbers? So just like with any word problems, I'm going to start by defining some variables. Let the numbers be x and y. So if they multiply to give 1, then x, y is equal to 1. And if they add to give 61 on 30, then x plus y is equal to 61 on 30. There are our simultaneous equations. So in this case, we need to make y the subject of one of these. I'm going to do this one here. So let y equal 1 over x, and then that is going to be substituted in here. All right, how do we solve that? We need to get that x off the denominator and the 30 off the denominator. So I'm going to multiply everything by 30x, like this. All right, what cancels? Nothing there. These x's cancel, and here the 30 cancels. So we end up with 30x times x, that's 30x squared, plus 30 is equal to 61x. Taking our 61x over 30x squared minus 61x plus 30 is equal to 0. How awful. Now, assume that it can be factorized. It can, but it's pretty awful to factorize. So let's just use the quadratic formula and cut our losses. So we are going to get x is equal to 61 plus or minus the square root of negative 61 all squared take away 4 times 30 all over 60. And tidying that up, we end up with 61 plus or minus the square root of 121 all over 60. And see, square root of 121 is 11, so it could have been factorised. But just using our calculator, we end up with 6 over 5 as one of the numbers and 5 over 6 as the other. So that's the end of the topic. Now it's up to you where you want to go to from here, but one suggestion is linear relationships.